we're going to use an IPython notebook for the tutorial. How many people already have IPython notebook installed on their computers? How many don't? Ah, okay. So if you can either install IPython notebook from the network, but we actually have two assistant tutors here who have flash drives with a bunch of things that we can use. So I think actually, is this on? Can you hear me? Yes. Okay, good. All right, so I'm going to dive right in then. We have, so Brian Tinsley and Alex Thomas. My name is Joe McCarthy. Oh, I better. And I'm a data scientist with Indeed. I use Python every day. I love Python. I used to teach Python. And I'm delighted to have the opportunity to share my love with the language with you. Alex and Brian are two of my assistants here. Anyone who needs to install software, raise their hands. I only brought 10 USB flash drives. So Brian and Alex will start moving around. The nice thing is this IPython notebook tutorial is also, I've got it in an HTML page. So even if it takes you a while to install the software, you'll be able to follow along on your own computer. And of course, I'm going to be doing all this live as well. Okay, so if you can reach me via Twitter at Gumption or via my email address there. I think the program lists me as my affiliation with Atigeo. I recently joined Indeed, but I'm still using Python every day. The intended audience for this tutorial are people who are familiar with programming languages that you've programmed somewhat before, but don't know or want to learn more Python. My goal here is to make this a rapid on-ramp primer to get you from knowing little or nothing about Python up to being able to understand more of what you'll see throughout the rest of the conference. I'll be restricting the focus of this tutorial to the Python standard library. And we're going to aim towards motivating this all the way along toward building Python function or set of functions to build and use a simple decision tree. So it's all grounded as much as possible, at least, in examples that are relating to machine learning and data science. There's also a sample IPython. So I'm going to be using an IPython notebook. There are going to be exercises in there. I probably tried to squeeze too much to fit within 2 hours, so I may not give you enough time to do them, but you can always do them later. And the solutions are in a file that's also available both on the, so if you go back here, if you go to this bit.ly link, PyData_tutorial, it'll bring you to the GitHub repository that has all the code. But if you don't have IPython notebook, there's an HTML version there that you can look at that will at least allow you to follow along locally. And then at the end, I have a link to a survey as I'm very eager for feedback to find out how well your learning goals were satisfied by this tutorial. Okay, so before I actually jump in, I joined Indeed recently, and I've had two reactions when I tell people I've joined Indeed. One is, oh cool, I love Indeed. The other is, who's Indeed? So I'm just going to give you a very brief overview. Indeed is the #1 job site, and it offers opportunities for both job seekers to find jobs. So here you can see I typed in Python data in Seattle, and it brings up a bunch of job listings for that. And you can search for a variety of jobs. You can constrain the search based on titles and salaries and so on. There's also, if you're an employer and you're looking for employees for free, so this is all free, you can post jobs and have them come up. And then you can look for people who have uploaded resumes. So I've deleted the names of these people, but for example, if you were looking for someone who knew about Python and data in their resumes as an employer, you could actually use Indeed to search for employees. And of course, if you wanted to spend some money, you could sponsor some job ads and they would appear prominently on the website. Okay, end of commercial. Oh, I'm sorry, one more thing. As probably every other person presenting at this conference, we're hiring. And we're hiring not just data scientists, but software engineers and a bunch of other positions. The Seattle office is growing like crazy, so please let me know if you're interested. Okay, So again, I'm delighted to have the assistance of two experienced Pythonistas, Brian Tinsley and Alex Thomas, who will both help you get stuff installed and or with questions that you have. We have a lot of material to go through, and if I don't get through, the nice thing is the IPython notebook has everything. And in fact, if you want to, you could get up and go to another tutorial. You've got what you need, and you could do it at home perhaps. But hopefully I'll add something that will to the process here. Okay, so in order to get started, we're going to first need to install or configure our Python environment. And there's two options that we're offering. One is Alex put together a virtual machine that has everything you need. So you'll still need to install Vagrant and VirtualBox, but we have that also on the USB flash drives we're passing around. And then you can get everything up and running in a virtual machine that will have no effect on your primary work environment. The other possibility is to install IPython and its dependencies and or Anaconda. As you probably know, Continuum is a sponsor of the conference. I'm sure they'd love to have you to use their free software package where they've pulled together the scientific stack that includes IPython and a bunch of other cool things, many of which you'll be seeing in other sessions here. Then once you've got that set up, you need to get the notebook. The notebook's also on the flash drive, but it's also in that URL I showed you at the very beginning. You need to launch the IPython notebook server and then open the tutorial notebook and you're ready. So this is what's on the 10 USB drives. Maybe I didn't know how many people, yes? I'm sorry? URL. I should have just put it in the bottom of every page. There it is. So bit.ly, I wish I had a whiteboard or something here. So bit.ly and then PyData with P and D capitalized, just like with the conference. There's an underscore there you might not be able to see, and then tutorial. Is that not working?
It worked for me.
Good. Okay. Ah. Case sensitivity. Are we good on that count? Great. Okay. Yeah, at any time, I get pretty excited and I start really kind of chugging through things. So if I start slowing down, feel free to raise your hand or, give me signals or something. Okay. So that's the overview we're going to be doing. When you get the flash drives, you'll see there's a bunch of stuff here. We have right over here, whoops. Oh, that's right. I actually have a key. Does it still work? Yeah. Okay, so that Python for Data Science Master is essentially just the download from GitHub. This Python for Data Science v6 is the one that's probably going to have the stuff you need. But you can see we have Anaconda for both 64-bit, 32-bit. We have even Python if you don't install Python yet. Vagrant and VirtualBox. So we have everything you need to get started. So I guess we'll make our way around here. And you can also go to the websites to get all this stuff too. I just suspect that if everyone starts downloading these 100 megabyte or more packages, that the network might slow down a little bit. Okay, but that's essentially what you need. Once you, if you use the VM version, you'll need to get all the stuff that's in there. And I'll show you here. Let's see here. Yeah?
One other thing, if you could copy those files from the USB drives and then give them back to other people.
Ah.
That's like them. I'm already out, so.
Okay. Yes. So I don't know if you heard Brian, please, if you have the USB, copy the files over to your local drive. And then, so if you raise your hand, if you still need it, keep your hand up. If you've copied the files, hold up the USB drive, and then Brian and Alex will know. Or maybe you can just hand it to someone nearby, and we'll just pass it around. Or you can, of course, try the network. Is anyone trying to load anything yet from the network? Is it going okay? Or?
Yeah, I can't close it very fast.
Oh, okay. So feel free in the meantime to, so this IPython install might be the simplest way, or you could just go to Anaconda. So if you just Google Anaconda, actually, is there some song or movie with Anaconda or something? That keeps on popping up above it. But yeah, you want the software package. Well, I should say in this context, it will be more useful to you. Okay. Anyone? I can pause for a little bit to give you more of a chance. How many people are ready to go at this point? Okay. What I can do is show you that if you do get the VM, let's see here. Okay, if you do copy stuff over from the VM, you'll see this. And you would then type, let's see here, I can't remember myself. Once you've installed stuff, you just run this command. So I just copy it from here. And the reason I did this is because sometimes, how many people are using Windows devices here? Okay. Sometimes people experience problems with I've heard reports, at least. I've never encountered them myself, where people experience it. So if you download Anaconda, you install it, and it's still not working for you, the VM is give you another option, and then you can wrestle with any configuration options later. It's all contained in a virtual machine. Okay, so I'm just going to type in vagrant box, add PyScience box. I'm going to essentially just type in that stuff before. Yay. And then I'm going to type in the next instruction, number 2. It says vagrant up. And this always times out for reasons I understand. But then it tries again and succeeds. I'm sorry, these?
Which notebook format are they?
Oh, Jupyter. So it's the latest version of IPython, IPython 3 or above. Okay, and then the last thing that happens is that it gives you this URL. So essentially, the way Alex has configured this is the VM is going to allow you in your browser to visit this page. Now, I don't know if this works with Internet Explorer. You can try. I know it works with Chrome, Safari, and Firefox. The IPython website suggests that Internet Explorer is not supported, but you're welcome to try. In the worst case, hopefully you have another browser available to you. So if let's see here, if I go and, so if whoops, wrong thing. Let's see if I got this time. Okay, so I'm just going to type 192.168.50.58888, and that's what you should see after everything's all set up. Okay, how many people are ready to go and look at the notebook so far? Okay. How many people still need the flash drives? Okay. How many people are done with their flash drives? Please keep them moving along here to the next person who might need them. Okay. Okay, so if you go to the IPython site, you'll see that the best way to do it. How many people here don't have Python installed yet? Okay, so I've actually got Python on these USB drives as well. So you can also download it. Just go to python.org and IPython is another open source tool that gives you a lot more capability in an interactive shell. but it also has this wonderful thing called an IPython notebook that allows you to edit text, run code, import images, and do all kinds of things right inside the browser. And I actually use it. This is my primary development environment because it lets me do the kind of exploration that Python is so good at without needing to worry about a lot of other things. So the two ways that are recommended here, if you're actually going to download stuff, you can go here, you can do pip install, and then make sure you do the install IPython and then in brackets right here, because you're going to need this extra dependencies that the notebook uses. And then if you can also choose to use Anaconda, so you can install Anaconda from the website, and then after you've installed it, though, it's often the case. So Anaconda releases new versions that have, when it releases, the most up-to-date versions of the 100 or so packages that they have or libraries they have bundled with it. But inevitably, in between releases, new versions come up. So after you install Anaconda, the next thing you should always do is type in conda update conda, and then conda update IPython notebook, and IPython Qt console. And all that's on the ipython.org/install page. Okay, so if you do install it locally, so I just showed you how to run it with the VM. Right, you do Vagrant, you do the first two steps, then you do, it'll show you the URL, the local URL you plug in your browser, and then you can get up and running with that. If you've installed IPython and or Anaconda locally and everything's running for you, the next step you would do is to grab this Python for Data Science, either download it from GitHub or from the flash drive and unzip it, and then you would type in from the directory containing the IPython notebooks, the files with the IPYNB extensions, you would just type this in a terminal or on the command prompt, IPython space notebook. And what that will do is that will bring up a window like this. Well, I'm sorry. It'll bring up a window like this in your browser. And essentially what it will do is it'll show you all the IPython notebooks, and actually all the files that you have in the directory where you booted up. Okay, and then the notebook that we're going to be using, or the one that I recommend, there's several versions of the notebook. So I've split one version of the notebook has everything split up into 5 different sections. This one right here is the HTML version. So if you're still not able to run IPython notebook locally on your machine, you can open up this HTML version and it will have everything that we'll be doing already done. So you can at least follow along and scroll up and down in case you need to go back and look at things. The one we're going to be using is clean. And what that means is we're going to be starting off with all the cells in the notebook that can, but they haven't been executed yet. So we'll be doing that as we go. And the other thing I'll mention is whatever we end up doing interactively based on questions that come up or other issues, I'll save this notebook and I'll upload it to my repository, calling it like _PyData or something like that. So if there's things I've done here, they're saying, wait a minute, what did he do? I don't remember. It'll be there. Okay? Okay, so that's the README text I just showed you. So that's the URL you'll type in. If you just type out the README file, it'll give you all the instructions for using the VM. That's what you'll see once you actually launch the notebook locally. And now we're going to dive into the notebook. Okay, questions? Okay, who still needs flash drives? Okay, good. So Alex and Brian will help move stuff around there. And meanwhile, I want to make sure I don't leave everyone too far behind here.
Quick basic question.
Yeah.
When you execute something and you want to reopen the notebook and not have it execute the whole mess on open, how do you configure that?
Actually, if you open the notebook, it won't execute anything until you execute it.
Okay.
So there are, I'm going to open my notebook right now, and I'll show you a few things about it. Okay. Here we go. So I've actually opened up the notebook. Okay. So in fact, here, you know what I'm going to do? I'm going to make a copy right now. So let's see here. I'm going to go to the File menu. Whoops. Oh, there. Okay. I must have selected it. It's making a copy of that entire notebook. Takes a little while. It's a very large notebook. In fact, at one point, this notebook used to be one of the first things that popped up if you Googled Python data science, but Google changed its rankings based on how long things take to load up, and now this, I don't even think it shows up anymore. Okay, now I'm going to come up here. What I did is I clicked on the name. Here, I'll do it again. So up here, I'm just going to click on where the file name appears. And I'm going to come here, and I'm just going to call it PyData 2015. Okay, so now I've made a copy of the notebook, and so any changes I make during the session now will be saved here. Okay. So there's a lot of things that I'd love to give a whole tutorial about IPython notebook, but I actually want to just use it. But you can save it periodically, but it will also automatically checkpoint it, I think, every time you execute a cell. So there's a few things you can see here. This is a heading cell here where it says Python for data science. And that's just a cell that starts with a pound sign. It's a markdown cell with a pound sign. Okay. This is just to enable the loading of images and displays. I'm not even sure I need it anymore. But if you go to a cell and you just hold down Shift and hit Enter, it should run it. It actually doesn't do anything. This is probably not an example, but we'll do something a little before. I just want to give you, though, a little bit of background here, but very little bit. As I mentioned before, the goal of this tutorial is to help you get up to speed as quickly as possible, assuming you already understand basic programming concepts and you just have to map them on this new language. The approach I've taken was motivated by the NLTK, the Natural Language Processing, or NLTK Toolkit book, where they start right into NLP issues. There's another tutorial today using NLP and NLTK, so you might see an example of some of that there. I'm assuming you're here because you have some interest already in Python. There's lots of other languages that are used in data science. Python, in my view at least, has the broadest collection of tools and capabilities that you'll want to use. R may have some better statistical properties, MATLAB as well, but Python kind of has all the data wrangling capabilities, the file manipulation. It just has the general purpose programming language that, especially with libraries, gives you a lot of power for doing the kinds of things that you want to be able to do in data science. So I have a bunch of quotes there. Again, you can look all this up later. I'm also assuming that you know something about data science, and so I'm not going to spend a lot of time here. The tutorial, when I first created this tutorial, it was actually a 4-hour tutorial with a dual use. One was teaching basic concepts in data science, the other was teaching Python. So I'm not going to spend a lot of time here because we're already running a little short or behind here. How many people have seen the CRISP-DM model of data mining? Okay. Again, I'm not going to go into this much, but one of the things that people, especially people used to software development in other domains, don't understand is the strong iterative nature of doing data science and how it requires business understanding, data understanding, because there's a business problem to solve. There's some data that you'd like to use to solve it. Sometimes that data isn't actually the data you need to solve it. You need to then manipulate the data in some way. It's usable by modeling or machine learning algorithms. You evaluate the impact, and then you deploy. We're really going to be focusing mostly on things that would be used in data preparation and or modeling. Again, I'm going to go right through here. Some basic terminology in machine learning. What we're going to be doing is we're aiming towards building a decision tree classifier, which is essentially a model that can be used to classify instances representing instances of a problem based on training that model or that decision tree on prior instances of the problem. So I find this example from, I think this NLTK book, very helpful in that you get these input instances, you extract features. In this case, we're going to be using features that are already extracted for us in a file. create a machine learning model that can then be used to classify new instances and assign a label. So what we're going to be using is the mushroom dataset at the University of California, Irvine machine learning data repository. And it's a very simple data set, but it lets us do a lot of things in terms of illustrating capabilities in Python. So this is a data set with about 8,000 instances representing mushrooms that have been classified in the past. And the way that mushrooms are represented in the data set is based on 22 attributes. Attributes that describe aspects of the cap, the gills, the stalk, and other features. So you can see there the full listing of features. We won't be going to most of these. The goal is to assign a classification of whether the mushroom is edible or poisonous based on its attributes. The way, let's see here if I can bring this, what does this link to? So there's a data file that's local here. I think I can just bring it up. Let's see what happens when I look. Yeah, so here's a data file. I'm not going to go into it, but it's just a bunch of lines, and each line has a single character, a comma delimited list of characters, each of which indicates a value of an attribute. Okay? So here's an example of one of the lines in that file right here. Okay? 23 comma delimited characters. The first one is the classification, P or E. Is it poisonous or edible? And then the other things, so then K means knobbed. So the second one is K, and then F means fibrous. N means brown cap color. You can see that they're not always the first letter of the attribute name. And do you get the idea that this is essentially a very compact encoding of each of them? Each of these represents a different mushroom that's been analyzed and stored for the purposes of training a model. Okay. Questions so far? Any machine learning issues? Okay. So a quick note. This notebook I originally created about a year and a half ago when Python 2 and Python 3 both existed, but it seemed like Python 2 was still the more prevalent version of Python. I'm getting the sense that more and more libraries are migrating to Python 3. And so after a nudge from one of the Python 3 committers, I decided to make a couple of, well, conceptually small changes, but I had to change a lot of stuff in the notebook so that this notebook will run under Python 2 or Python 3. I'm not going to go into the differences between the two versions of Python. You might see a smattering of these, but I will just briefly illustrate what the differences are relevant to what we're doing here. So first of all, I'm going to put my cursor here in this cell, and then I'm going to go up here and go to the Insert menu, and I'm going to say Insert Cell Above. Okay, and so the two things that are going to be different are the way print works and the way division works. So in Python 2, you could type in print 1, 2, 3, and it would print 1, 2, and 3. And see if I insert another cell, print 1, 2, 3 would print 1, 2, and 3, but within parentheses. That's something known as a tuple that we'll cover in a minute. And then the last thing I'll mention here is if we say 1 divided by 2, it would use integer division. Okay? So then, now I'm going to say from the future, in this case I've got Python 2 running, so the future is Python 3, import the print function and the division operator. So I just hit Shift Enter again, and actually, you know what? I'll come here. There's actually some useful shortcuts here that you can look at. And I forget. So what I'm doing is this one right here, run cell select below. If you hit, I think that's Control Enter, it will just run the cell and not do anything. Or you can do Alt or Option Enter, and it will run the current cell and open up a brand new cell underneath. Okay, so you can refer to that if you want to do some shortcuts. Okay, so now I'm going to so I'm going to hit Escape B, which opens up a new cell underneath. I'm going to hit Enter, which now puts my cursor into that cell. And now I'm going to once again say print 1, 2, 3. And it's going to give me an error message because print is no longer a statement, it's a function. And as a function, I have to give it arguments inside parentheses. So I will, let's see here. So I will say, now I'll say print, whoops. Now I say print, and I give it the arguments 1, 2, and 3, and it does what the old print statement did without the parentheses. And then the other major change, or noteworthy change here, is, is that if I now say 1 divided by 2, it's going to give me floating point arithmetic values. Okay? So, questions? Okay. So now, for the rest of this, I'm just going to go through a bunch of aspects of Python, kind of dig into Python. So as we saw before, the mushroom dataset is just a file with a bunch of lines containing common delimited attribute values. Okay, so that can be represented as a string in Python. So if I have a string here, if I just evaluate it, it's just going to come back as the string. But what I usually want to do is take a string and assign it to a variable. And the way I do that is just say variable name equals and then the string. And then if in the same cell I just type the variable name, it's going to return the value of that variable name. Okay? So identifiers in Python are similar to others. They're a combination of letters, underscores, and numbers that have to start with a letter or a number. Here's some examples of printing. So I have several things that I want to print. I can print them out. And then I can also, there are times when it's helpful to keep the cursor, the output cursor, on the same line and not advance the next line in the output. And I do that in Python 3, and now since I've imported the function into Python 2, by specifying an end operator. So you can see here, so here I'm printing A, B, whoops, I should run it, I guess. Yep. Okay, so I've printed, let me scroll up. So you can see subsequent print statements automatically put things on the next line. If I specify an end keyword, and we'll come back to that in a little while, but I can specify end equals some string, it's going to add that string to the end. So in this case, I actually have a new line character, which is the \n character, so it's actually still going to go to the next line. And you can see it's going to put ... but then go to the next line to print the C. But if I instead give it an end value that has something that doesn't include new line, the output cursor is going to stay in the same line. So now when I print C right afterwards, it's actually going to appear on the same line. Okay, now it turns out that's useful, especially when you're printing things within loops. Sometimes you want to print things across on the same row. Okay, I've also included some comments here. Comments, the comment character is the £, and the common standard is to suggest that you skip 2 spaces before the comment character and a space after the comment character. You can actually have multi-line comments by simply creating multi-line strings. And the way you do that, instead of having a single quote delimiting a string, you have 3 quotes. And they have to be the same type. So 3 single quotes or 3 double quotes. And actually Python is agnostic. You can use single quotes and double quotes in almost any context. You just can't interleave them. So if you start off with 3 single quotes, you have to end it with 3 single quotes, and vice versa. Okay, so you can see if I just evaluate that cell, it just inserts new line characters into it. And if I have it in the middle of a block of code like I have here, it's not going to print anything. So I could put anything where it says this is a multi-line comment. And then if I want to print it, it'll actually convert the new line characters to new lines in the output. So it's also the way I can have multiple lines of input or output encoding in a simple way. A lot of what goes on in Python, and one of its powers, is that the lists that it provides. So you can have lists of elements. They can be anything. In this case, what I'm going to do is a very useful thing is to be able to split a string based on some delimiter. So in this case, I'm going to split the single instance string based on commas and assign that value to a list. And then I'm going to print the list out. So what that's done is taken each of the characters in between the commas, broken out into a separate element, and stuck and put it in a list, which is essentially a data structure that has square brackets at either end and any number of elements in the middle, including none. Now, lists in Python are heterogeneous. We don't have to declare anything. We don't have to declare any types or restrict it. We'll type that in. So I can have a mix of characters, numbers, integer and float, Boolean values, and even lists within lists. And everything's fine as far as Python is concerned. Another cool thing about Python is that you can use the plus operator either for addition if you're using numbers or concatenation if you're using lists or strings. Okay, so there's an example of adding numbers, of putting together a bunch of substrings, and then actually concatenating the list I showed up there, giving the same result. In order to access individual elements of sequences, where a sequence so far is either a list or a string, but it can be a few other things as we'll see in a little bit, we can use a bracket notation into which we can insert a reference, an integer value that will give it the zero-based position of the thing we're trying to look for. Okay, so here, for example, I'm going to print the entire single instance string and then the third element, right? Because 0, 1, 2, that'll be the third element, and likewise of the list. Okay, so you can see here that the K is the third element here, but when we split it up, F is actually the third element after we split it on the commas. Okay, negative index values can be used to work from the end of the list. So you don't need to say how long is the list and then manually do that. You just say -1. It'll grab the last element. And if you say -2, it'll get the second last element. Okay, so there again, there's the D, which is the last element, and the comma before the D is the second last element. And that can be worked with lists as well. Okay, only here we don't have commas as elements because we split them out. So we can actually specify not just individual elements, but subsequences. So for example, I can print out the elements between 2 and 4, 2 up to but not including 4. So that's actually the third and fourth element of the string. I guess I don't have the string on the screen there. So I go over, oops. So the 0, 1, 2, 3, so it's going to give me the K and the comma right there. Okay, so when you have slice notation, it's going to give you the first element and everything up to, but not including the second element. Second slice element. You can also use negative values inside slices as well. Although they still need to go from smaller to larger. Okay, so this is going to give me the fourth to last element up to, but not including the second to last element. And then using these slices, we can actually omit the start or the end to get subsequences as well. Okay, so if I want to get all but the last element, I just say, give me everything but the last. So starting essentially at 0, and then likewise get me all but the last 2. Or if I say if I want to get all but the last 1, I can say 1 colon. And then all but the first 2, all but the first one here and all but the first 2 there. So I can use this slice notation very flexibly to do a lot of common things that we often have to do with a couple lines of code in our languages. Okay, and same things with lists there. Now, I might be going into the weeds here, getting into too much detail, but to me, this is part of what makes Python so powerful. Is all these things that often require additional lines of code in other languages can be done quite simply. So here's an example where if I want to take every other element in a list, there's a third optional element called the step that is optional. You don't have to include, but if you do include it, it will essentially tell you what the step size is to access elements. So if I say, give me, if neither of the first 2 things is specified, it just says from beginning to end of the entire structure I'm passing it, taking every other one. If I say start at element 1, which is actually the second element, and then give me every 2 elements, I'm going to get the odd numbered elements. And then if I use -1 and don't specify anything else, it's going to, in effect, reverse the thing I just passed it. The Python tutorial has a handy way to think about this because this actually took me quite a long time, and sometimes I actually have to do simple examples just to convince myself I'm still thinking about it right. But so if you say 0:1, essentially it's going to give you everything from 0 up to 1, but not any further. And if I say, remember before I said 2 to 4, then it's going to give me this one, but not that one. And then similarly with a negative sign. So if you think about the slices essentially referencing the sort of the places between the elements, it's easier to remember, I think, and apply. Okay, so Python doesn't have a semicolon or other mechanism to explicitly say this is the end of a statement. You just go to the next line. Okay, and the way it understands blocks of statements is that they are all at the same indentation level. We'll see some examples of that in a little bit. You can, however, break a statement where there are commas. You can break them wherever there's a comma, a parenthesis, or a bracket, for example. Okay, and it'll assume you're going to continue. Because here, for example, I've said attribute names equals, and I gave it a starting bracket. That means, this is a list. So I say, here's an element, comma, and the interpreter knows, okay, there's more to come because I haven't seen the closing bracket yet. And it will just assume that it will do that. And actually, IPython will automatically indent everything there for you. And then I can print them out at the end. Oops, I guess I'm a little fine. There we go. And we see it's all together. Okay, so now I can also break that in a print statement. So I can put a bunch of printing things and then a comma and then continue it. This happens frequently, especially with voluminously labeled output. I put a comment here. Notice that there's no backslash needed when you're breaking after comma. Unlike here. Here I'm trying to break up an arithmetic expression, and it doesn't have commas in it, so I have to put the backslash character right before I hit enter. Do not put a comment there because then that'll throw everything off. You'll get an error message. So if I'm breaking either on a comma boundary or after a left parenthesis, no problem. I can just keep on typing stuff and it will assume that's all part of the same statement. Questions so far? Is the pace okay? Okay. Okay, processing strings and other sequences. So if you read in a line from the file, sometimes there might be initial tab characters or other sorts of things. I just actually stuck this in. So I've created here is that first or that example line from the code, but I actually have a new line character at the end, and I put a tab character at the very beginning. And then I also put the asterisk in there just so you can see what happens. So if I go here, you can see that it prints out a tab, and then the string, and then a new line, and then because there's a comma here, it's going to put a space. Anytime there's a comma character, there's going to be a space inserted before the next thing. So you don't actually have to include extra spaces if you have a bunch of things that you're printing on the same line. So it goes the new line, prints a space, and then gives us the asterisk. If I use the strip function, or actually the string method, it'll actually strip any leading and trailing white space and then print that out. So if I now go like that, it'll do that. Now I guess what I forgot to show here, I'm going to hit escape C and then escape V, and it's going to copy that whole thing here. But if I were to say, I don't know, do that, and then I don't know that, whoops, and then okay, it does not strip things from the middle. It only strips leading and trailing white space. But actually, that's often what I want to do, at least when I'm processing strings. Okay, so very common need is to process CSV files, comma separated value files. So there's actually a CSV library in Python that I actually recommend that you look at, but I'm trying to minimize references to additional libraries here and keep things simple as possible. So here I'm going to reset single instance string to the string as it would be read in. If I read in a line of that file, I would get a string that has all the things on it plus the new line character. And a very common thing that I want to be able to do is strip any leading or trailing white space and then split on whatever that character might be. Okay, so there you see the original string, including the new line, and then the stripped version of it. One of the cool things I love about Python is this join. So it's the inverse of strip. you know how sometimes you want to write out a comma delimited list, and then you either have to write out everything but the last thing, and then write the last thing because you don't want that trailing comma, or you have to do some kind of workaround. If you instead use the join operator, you can get away with that without having to do that extra work. Okay, so you can just say, whatever you're going to have to insert as a delimiter to a bunch of words, or actually strings, you can use the join operator for that. And then there's a length function that will just return the length of the thing that you pass it. Very common in our languages. There's an in operator, which operates as you might expect. It's just going to check to see whether a string is in another string, or you can actually check to see whether it's in a list. The comma is in that original string, but the comma is not in the list, right? Because the list is composed of things that are not commas, because commas are the delimiter. You can also count things. So you can count the number of commas in the original list. There's 23 attributes, that means there's 22 commas. And then there's 3 occurrences of the attribute value f, even though f means different things in different contexts. If you scroll back up to the top, you'll see that. You can also find out what is the first position of a character in a string or a list, okay, by using the index method. Note, however, that if you look for something that is not in the list, you'll get an error. Okay, we'll come back to how to. There's a couple different ways we can deal with that in a moment. I'm sure you already have some programming paradigms that you're probably already aware of in our languages to protect against that. But before we do, I just want to mention a little bit about a very important concept in Python is mutability. I think mutability issues may be the most common thing that messes me up if I'm deep in the middle of debugging and I realize I've actually modified something that I didn't think was modifiable because of the way that Python passes parameters. So this mutability thing is important. Python strings are immutable. You can't, if you assign a string to a variable, you can't go and then modify the variable. You can do something to the existing variable and assign it back, but you can't change the value of a string. Lists, however, can be modified. So, for example, here are a bunch of different things you could do with a list. So there's a list with a bunch of numbers. So I'm actually creating a list, and then I'm saying list2 equals list1. What that's going to do is now both list1 and list2 are going to point to the same object in memory. It's not making a copy of it. It's just, they're pointing to the same thing, which means any changes I make to list1 are going to also be shown in list2. So I'm going to set list1 to a list, set list2 to point to list1, that same list, and I'm going to do a bunch of stuff to list1. I'm going to remove an element. I'm going to append an element. I'm going to sort and reverse it. Okay, so I can remove this. This will remove the first occurrence of 1 in the list. I can append something to the list, which will add it to the end. There's actually an insert operator that will let you provide a next position into which to insert something. You can sort and reverse it. And you can see there that there are a bunch of changes that you might expect to be made. And then at the very end, though, what do you think the value of list 1 is right now? Okay, that's one option, right? It could be 2, 3, 4, 5, 6, except the very last thing I called was to then reverse it. So that means it's, so list 1 is now that last thing. Each one of these things destructively modifies the variable that was passed. And list 2 is kind of riding along because it's pointing to the same thing in memory. Okay, so just something to bear in mind. Actually, I'm going to show you a little trick here. So I just did a copy of this. I'm going to move this down. See this arrow right here? I'm going to shift this cell down. And now I'm going to say list 1 bracket colon. List 2 now has a copy of list 1. Okay, so essentially, because I used the slice operator, it's going to return a value, and once it returns a value, that new value returned from list operator or from the slice operator is going to be bound to list 2. Okay, so now if I go through all these things again, it's going to make all the same changes, but now if I copy this, so escape C, escape V, I'm going to click on this, move it down, and now the changes I made to list 1 are not carried along because list 2 actually got a copy of list 1. Okay? Yes?
How would you remove an element using an indice instead of the actual value of the list type?
That's a good question. You could either construct a new list with everything but that element. Is there, you know, Alex, is there an element, is there a remove option? Is there a different method? I don't know that, but I'll look it up afterwards, or if anyone else looks it up. The Python Live, here, let's see. Anyone know?
I think you can delete by index on a list, right?
Yeah. There's something in there. If you look under the go dir parentheses list, it should give you a list of that.
Excellent, yes, then that would be a good thing to know in general anyhow, so let me do that. The dir, if you call the function dir and pass an object, it will tell you all the methods, actually all the attributes that are associated with that object. Okay, so we're not going to go through all these, I promise. And the ones that have double underscores have special meaning. But there you can see that there's append, count, extend, index, remove, reverse. Okay. Whoops. Now, I'll have to look that up. That's a good question. Maybe someone else can figure it out. But I do want to know that now that you've asked it. But I'm going to keep moving around because I don't want to get too far behind. Okay. So we saw before that when you call sort, the method sort on a list, it destructively modifies the list. There's a function called sorted that does not destructively modify its argument. Okay? And there's also one called reversed, or reverse D, that does not destructively modify things. So here we can see that if we have list 1 and we call sorted on list 1, it returns a sorted copy of list 1, but doesn't actually modify the list. You can also call sort or reverse on a string, but notice that if you call sorted on a string, it's actually going to return a list of the elements in sorted order. Okay, so that's something to bear in mind. It's going to return a list, but doesn't modify the string. There's also a keyword argument that you can pass to sorted that can specify whether you want it to be sorted in descending order, and that's to say reverse equals true. Okay, so if I call it on that string and say reverse equals 2, it returns the elements of that string sorted in descending order. So there are strings, there are lists, and then there's tuples. Tuples are a lot like lists, except they're immutable. They can't be changed. And it turns out you can do a lot of cool things with iterators and generators, and there's ways to use tuples instead of lists that make it a much more efficient data structure to use in certain contexts. We're not going to really get into that today. So here's an example of a tuple. Actually, you can specify, I just want to mention one thing here, tuples. I'm going to insert a new cell here. So if I say the empty list, it's going to do that. But if I say 1, it's going to return 1. Because by itself, it interprets a single integer, for example, inside parentheses as an expression. And so it's just going to, as though I'm going to control the order of expression. So if I want to create a tuple containing 1, so let's see here. I need to specify a comma. And the comma says, oh, wait a minute, this is a tuple, even though it only contains one element. Okay? So there's a bunch of things I can do with tuples, same kinds of things I can do with lists, except and strings, actually more like strings because it's not a mutable data structure. Okay, if I try to append something, so x now is a tuple of 5 elements. If I try to append something to it, it's going to generate an error because it's not a mutable data structure. There's no way. And actually, if I were to do a dir on x, you can see there's a count and an index method, but there's no append or reverse or sort method associated with a tuple. Okay, but there's workarounds, right? You've done this kind of thing before when you're dealing with immutable objects. You just create a copy of it, you stick something in the beginning, and then reassign it back to the object, right? So here I can say, if I wanted to actually add 6 to the end of it, I can say take the value of x, concatenate a new tuple that has just the element 6 in it, and then reassign that to x. Okay, and now I've got 6 at the end. And there's a shorthand operator. Many languages have this kind of shorthand operators, right? The auto increment, or you could say, whenever you have a general pattern of name equals name plus whatever, you can just say name plus equals whatever. So here, for example, I can generate something to put the 7 at the end as well. Okay, so conditionals can be used to, you've seen conditionals in other kinds of languages, so the same kind of thing here in Python. There's an if statement which has the keyword if, and then some Boolean condition. In this case, it's going to check the value of class the value of class value. It has a colon at the end of the if line, and then some statement to execute. And then if you have else ifs, those are represented as elifs. So you can have any number of else if combinations there, and then a final else. Okay, so one of the things here, try changing this to p or x, and whoops. So if I change that to p, it'll print poisonous, and if I try it to x, it's unknown. Okay? Now, before we had an issue of an error being generated when things are not found. So before we call index, we could first check to see whether attribute is actually in the attribute names. And if it's not, then don't call it. Okay, so now so here, instead of generating an error message, we actually get a potentially informative print statement that tells us, hey, it's not there. And then if I change this to bruises with a question mark, it tells me the position of that.
How do I delete the result if I delete the result?
Delete the result?
Yeah.
You go up here to cell.
Like I never read it.
Yep. Cell, current output. Whoops. So this is a cell menu. Clear. And you say current output, clear.
Thank you.
Yep. So one strategy or paradigm that's adopted by many Python programmers is asking forgiveness rather than permission. And most languages have some kind of try-catch kind of a loop and so on. But I haven't encountered a language where it seems so much the norm to ask permission, or excuse me, ask for forgiveness rather than permission. So I'm just going to demonstrate it here briefly. You've probably seen this kind of a thing, but I'm just mentioning it because you see a lot of this especially if you could open source Python packages, there's a lot of try and accepts. Okay, so now an alternate way of doing exactly what I just did up here is to just go ahead and try and assign I the value of the index of attribute and then print out its position. If it raises a value error, then it's going to, and I have an except that flags the value error, then the statement underneath that except will be what's executed. Okay, so once again, I can do that. Bruce is not found. And Bruce is in position 3. So it's just an alternate way. You've probably encountered this in other kinds of languages. I'm not going to adopt that here just because if you're not used to it, it's not necessary to use the language effectively. As usual, what it comes down to is how often you expect the error to occur and how expensive is it when it does occur.
What's the scoping in Python? If, for example, that was declared in the try, would it be accessible in the except?
You want to know, like, does I have a value right now? So in other words, does I still have a value?
The scoping, the try value could be accessible in except. Like, for example, the attribute is declared globally,
Uh-huh.
and it being declared inside try.
Yeah, so I is actually still has a value.
Oh, okay. Oh, yeah.
So, yep.
Okay.
Other questions? Okay. The Python null object is the keyword none. Note the capitalization, capital N-O-N-E. Okay, so there's an example of it. The value of it when you print it is just none. None has some special qualities that we'll mention in a little bit. Okay. A lot of times what we really want to do is define functions for things we're doing over and over again. So the way that you define a function in Python is the keyword def, followed by a name of the function, followed by some parentheses enclosing the list of 0 or more arguments or parameters that are passed to that function. So here, for example, if we wanted to write a function that would return the value of an attribute, we could define a function to do that. Essentially, all I've done is wrapped the code up above, and then the other thing to note is that there's a return statement under each of the if and the else. Okay. So I can define a function attribute, and then I can pass it cap shape as a parameter. So here I'm calling the function. I'm passing it a list representing a single instance. This is going to be bound to attribute the parameter attribute inside the function, and then the list of attribute names as well. Questions on that? Yes.
Do variables have a concept of locality?
Yes, you can. If you declare variables local to the function, it's only accessible inside that function. So here, yeah. Well, let's see here. Let me. Oh, and then I'll move this down here. And actually, I'll move this down here too. So in that case, I did not get altered because there was a local I inside the function. Unlike before when I executed at the top level, the try did not have a local scope. Other questions? Okay. This is an important thing too. Python does not distinguish between functions and variables as far as the use of names. You can have a name or an identifier associated with a value of some kind, and that value could be a function definition. So what I'm doing in this cell right here is I'm first defining x as a variable and assigning it the value of 0, and I print it out, and then I define a function called x, and then I print out x as well as its type. Okay, so that's something to be aware of too. In other languages, sometimes you can get away with having variables and functions of the same name because they're used in different ways, but that's not the case in Python. There's also the preferred way of checking the type of an object, especially if you're doing object-oriented programming, and class inheritance is part of the mix. It's called isInstance, and you pass an object and class. There's an example of that later on that we'll come back to. So one of the things that regularly throws me off is remembering that Python has a notion of passing parameters in a mechanism called call by sharing. What that means is it's mostly like call by value in that if you reassign a value to a parameter inside a function, that assigned value doesn't get retained after the function is done. But if you modify the thing that's passed, and it's a mutable data structure, then those changes will be retained. And this is a rather contrived set of examples here, but essentially here I've got modified parameters. I pass in two things. I'm going to call insert, which is a destructive operation. It's going to modify the list. And then I'm going to show what it is, and then I'm going to I'm not going to destructively modify parameter 2. I'm just going to assign it a new value inside the function, and then we'll see what happens. In the main outside of the function, I'm going to assign argument 1, the list 1 through 3, and then argument 2 is going to be 4 through 6, and then I'm going to show what their values are before, during, and after the call. Okay, so you can see that before calling, they have the values we assigned to them. Inside the function, we inserted x here. It didn't actually modify, I guess I should have modified that description. Oh well. You know, I reassigned the value of parameter 2 to this list 789. So they have those values there. But now I come back from the function. Nothing changed with with argument 2 that I passed in, but the x is still there in argument 1. Okay, that's one of the reasons it seems like a niggling thing, but actually can lead to all kinds of problems if you don't understand what can happen when you do this. So it's important to be very mindful of the way that you use destructive operations. And in fact, I've actually gotten away from using them unless I'm absolutely sure that the destructive operations I do that's okay, because I never want to use this thing again after I'm done, which is pretty rare. Okay, and here again, this is just using that, remember the bracket colon bracket? I can make a local copy and everything's fine. So this is the same function as before. But because I made a local copy of parameter 1 before I did the insert, everything's fine. Okay? And you've probably used similar kinds of mechanisms to work around things. Okay. And then the other possibility, of course, is I can just insert the x by saying concatenate a list containing x with what's already there in x. And that has no difference because, again, I'm assigning the value to the local or the parameter inside the function rather than destructively modifying. I'm just assigning a new value, and that only has value. That value only persists within the scope of the function. You can return multiple values from a function, and when you do so, they come back as a tuple. So, for example, it's often useful to find both the min and a max of something. So here's a little function that just, given a list of values, returns the min of those values, comma, the max of those values. And then back when I use that, so I'm going to create a list here. I'm going to print it out. I can assign the value returned by that function to a single element, and that's going to make the value of that variable a 2-element tuple. Or I can unpack what's coming back and say, you know, x comma y, or in this case min list 1 comma max list 1, and because I know it's returning 2 values, it'll automatically get assigned to those 2 values. And that's really helpful in a lot of when you're iterating through something and you're binding 2 different values. But I don't know if I don't have any examples of that here. Okay, so iteration. It has a for statement that will iterate over some kind of iterable list, a sequence, or just about anything. The for loop here will just iterate over each of the elements in this list and print out its value. And then it can also be used with a string or any other sort of thing.
Question.
Yes?
Not necessarily about loops, but suppose I moved a box up or down, or a cell up and down,
Yep.
and I want to do undo. How do I undo?
So right now, if I'm right here, I want to insert a new cell underneath.
And I moved it up by mistake.
Okay.
I don't know how many times I moved it up, and I want to do like undo.
Oh, you can undo delete cell. I don't think you can undo move cell.
I think you can select the cell and do the down switch button.
Yeah, you have to
I
manually.
don't know how many times I moved it up by mistake.
Yeah, I've done that a lot too. I don't know any way to do it. I just have to end up manually moving it. And actually, the screen I have at work that I use IPython notebooks, I have in portrait mode orientation because it makes it easier to move stuff around. So yeah, I don't know of any way to do that. Okay, there's a range function that you can pass an argument to that will return all the elements up to but not including that value. Okay, so for example, I can iterate now through if I take the length of the attribute names and I want to iterate through, make I the value of 0 up to the length minus 1, I can use that to print out the attribute of the name of the value of every attribute. So essentially what this is doing is for each element, I'm printing out the ith attribute name, an equal sign, and I'm calling the function that we defined above called attribute value, passing it that instance, sending it the attribute names, the ith value of attribute names, and then the list of attribute names. And that's going to extract the value of it and print it out. There's a more involved version of range that lets you specify not just stop, but you could say the start and the stop. and you could even also have a stepping value as well. Okay, so here, for example, if I wanted to print the values of 3 down to 0 by -1, it'll print out the values. What do you think is going to happen when I execute this? How many values are going to come out? What's the first value? Okay, what's the last value that's going to come out? 1, right? Because it's going to be everything but the last thing. So it's going to print 3 down to 1. Okay? The first version of this notebook I used used an iterable version of a range called xrange that is much more efficient, but I stopped using it because xrange is no longer defined in Python 3 because everything in Python 3, or wherever possible, they use iterable methods, which are because of their efficiency gains. So I'll just let you know that if you end up using this exclusively in a Python 2 environment that you don't expect to migrate to Python 3, then xrange is good to use. Yes?
For the loop, does it have a for each for the list or
I'm sorry?
does it have for each loop?
A for each loop?
Yeah, does it
In my mind, at least, if I'm interpreting correctly, the for does kind of operate as a for each. So, for example, here, it went through each element. So here, even though I had a list of 3 elements, I just printed out the element. So for each element in the list, so if you don't pass it, so you can use it as a for each. As if I'm interpreting correctly as far as our languages.
And in case of a associated array, do you have
Yes, we have dictionaries that are similar to associative arrays or hash maps in other languages. Okay. So far, everything we've been doing is in this, everything's self-contained in this notebook and part of the standard Python library. However, in the exercises down below that we'll be getting to in a moment, there's another file I've included with this distribution called SimpleML. And that SimpleML is a module, where a module is just essentially a file, a Python executable file that has usually a collection of functions, class definitions, and or variable assignments or other sorts of things that you might expect to find. And you can import that module and then use the functions and or variables defined in that file by using what's known as a dotted notation. So you specify the dot. So for example, with SimpleML here, you could specify SimpleML dot and then print attribute names and values and then pass it the arguments, and it will invoke this function as it's defined in that module. And the reason I'm showing you this here is because there are some exercises coming up, I think just below the horizon here, where you can try to define a function and then see if it works. And if you use the SimpleML version of it, you can see how it should work. And then you define your own function, you just delete the SimpleML dot, and it will, you can go back and forth. And I'll show you what I mean down below here. So here's our first exercise. Define print attribute names and values. The goal is essentially to do that. Okay? So for this very first exercise, I'm going to just kind of step through it so you can see what I mean. But essentially, we're just, you could just print out those values. And in fact, given it's 11:15, we're running short. I spent more time getting the stuff installed. So I'm actually just going to copy the elements of that cell down here. But first, I'm going to evaluate this cell. And notice that I'm importing SimpleML, and I'm invoking the print attribute names and values function there. Whoops. No, I don't. Okay, so you can see it's doing the same thing as above. And now what I'm going to do is, if I had more time, I'd let you work on this. I will take a break in a moment to let you do a little bit of work on something. Or actually, I'll pull you. So I copied the elements from the cell above, but now I have to indent everything. And what I did, I just marked the region I wanted and hit tab, and it moved everything over. Because Python delimits blocks by their indentation. And the default is 4 spaces, or and usually spaces are used instead of tabs. Okay, so now essentially I'm defining a function to do what I did up above, and now I'm going to simply whoops. I'm just going to make a copy of this line. I'm going to comment that one out, and then delete that. And now I'm going to be copying my local copy of the function definition. Hopefully it works. What do I do? Oh. I don't know why I ended up over there. Okay. So in each of the exercises down below, and given the time, I don't think we're going to have a lot of time to do them. In each case, if you want to experiment and try your hand at doing some of those exercises, you can just do what I just did there. You can type in the code. I just copied it, but you can type in the code right here in the cell, and then you can call it there. And actually, I think I will for the next exercise, I think I will give you a chance to do it because I want to make sure you get a chance to make some mistakes. You might not make any mistakes, but it's often helpful. I learn way more from mistakes than when I do things right myself. And unfortunately, I make lots of mistakes, as Alex and Brian can attest to. Okay, so file I/O. So in order to read from a file, we have to open it up, just like in any programming languages, other programming language. Python provides a nice structure wherein you can use a special construct called the with statement, where you can say with and then open and then a file name and then the mode in which you want to work on that file, usually read or write. And then you can do a bunch of stuff, and then after the with statement, it automatically closes the file. And that way you don't have to issue a separate close file, a close call. You could still use f.closed if you wanted to. Another kind of cool thing is this: you can iterate through each line in the file just by using a for loop. So once you've opened up a file, so here I'm opening up a file, data file name, which I've set to agaricus lepiota. I don't know my mushroom names or pronunciations very well. And I can step my way through the file, and line will be set to each line in F each time through the loop automatically, which is kind of nice. I don't have to do a special call to like a read line or a read or anything like that. It's just going to automatically iterate through it, returning just a single thing at a time. And then what I'm going to do is I'm just going to, every time I read a line, I'm going to strip the new line character off the end, and if there's anything at the beginning, like any extra spaces or a tab character, I'm going to split it just like we did before, and then I'm going to append that split line, which will now be a list of attribute values, to the set of all instances that I'm collecting. And then at the very end, I'm just going to print out the number of instances I read, and then the file name. And then just for confirmation, there's 8,000 instances I don't really want my Python notebook to be consumed with so much. I'm just going to print the first one. Okay. Questions about file I/O? Okay. Good. Here's your chance. So now you write a function called load instances that essentially opens up a file, reads in the elements of a file, appends those things to a list, and returns the list as its value. Okay, so I'm going to pause here for a moment. I've got a solution out in this simple ML file here. So I'm going to copy this again just to show you what I mean here, how you can test this. And I'm going to so right now, okay, so you should, when you write your function, it should work the same way. Okay, and if I go here, if I delete the simple ML period, now it's using the local function I'm defining in this notebook. Okay, and it's giving me an error. Do you know why it's giving me an error? How many elements are in the all instances list? 0. So what's the first element? There is none, right? Okay. Okay, so I'm going to pause for a couple minutes and let you spend some time doing that and hopefully making some errors and seeing what happens when the indentation isn't quite right and so on. As you may have noticed, there's a lot of similarities in this function and the code we just executed, so hopefully it won't take you very long.
Just real quick, that list index thing, it's the pop method that allows you to do it by index. Remove it.
Oh, and that has the optional argument to specify where. Thank you. Okay. So, oh, she just left. Oh, well. Oh, good. Okay. So if you didn't hear that, so there's a pop method that you can use on a list that let you specify an index position from which to remove an element. And if you don't give it that argument, then it will just pop the first thing. Thanks. Yes. Uh-huh. Yep. Just run it. Yeah. So. Yeah. So if I double click there, you can see I tried to adjust the fonts through some mechanism in the Markdown language. Yeah. So but then once I'm in that mode, I just run it. And also this play button will run a single cell as well. Yep. How many people are done with the exercise? Okay. I'll give you a few more minutes. How many people are done now? Okay. Goodness, it's 11:25. I think I'm going to press on, just in the interest of time, so we can cover as much material. But the nice thing is, lunch is right after this session, and I'm happy to hang around for a while if you have questions, and I'll be around for the rest of the conference too. So. And of course the solutions are in simpleml.py if you really want to see as well. Okay, so there's also ways of doing output to a file, and that's by using the write method of a file object. And if we want to write stuff out, we can actually combine words into a single string and then call write. So say, for example, I want to be able to take the instances, but instead of having them use comma as a delimiter, I want to use a pipe delimiter. How many people have dealt with pipe delimited files? Okay, it's because pipes are relatively infrequently occurring in many text values, but commas occur quite frequently, so pipe is a common option. Okay, so what I'm going to do here is I'm going to define a variable delimiter. There is no such thing as a named constant in Python. There's no way to say this cannot change. So the best thing you could do is use conventions. So maybe all caps, for example, and then just treat it as a constant. But there's no way to make sure it doesn't change. And I'm going to convert the set of strings using that delimiter. And I'm going to create a new file. And I'm going to give it the name agaricus lepiota-2.data. I'm going to open up the file. This is data file 2, not data file. Using W for write, I'm again going to call it F. And then for each instance, I'm going to use that delimiter to join the attribute values in that instant together. And then I'm going to append a new line character to that joined list, which returns a string. Okay. Then what I'm going to do is create another variable called all instances 3, read it back in, and confirm that there's something in the file. Okay, a very lightweight check. I really should check some more things than that, but and there we have it. Questions on that? Okay. One really powerful mechanism in Python is called a list comprehension. So it is often the case that we want to actually build a string, and And for example, if we had a list of tokens A, B, and C, and we wanted to create a delimited string, we could iterate through all but the last of those tokens, adding it on to the string plus a delimiter, and then adding the very last one manually. Okay? But we could also do the same thing with a list comprehension that essentially says for token in token list, return token. So the basic idea of a list comprehension is you have a for loop, and the first thing in the list is the thing you're going to be extracting from the for loop, and then you have the for loop. So where you have a pattern where for x in y, you do something with x, you can actually create a list automatically in a single expression by capturing that. Okay. There are several examples of list comprehensions throughout this, and in each case I show you both ways. This is a tremendously powerful mechanism. I use it a lot. It cuts down the code, and to me it improves readability. But I've worked with other people who have less experience in Python who just can't wrap their heads around list comprehension. So to make sure that this doesn't trip you up, I have both versions throughout the whole notebook. Okay. So one of the things that happens in machine learning, how many people here have experience in machine learning? Okay. So how many here have dealt with data where you had missing values? Okay, a not uncommon occurrence, right? And as you know, there's a lot of different ways that you can deal with the missing values. You can impute them in some way. You can take averages. There's all kinds of things. Or you can just say, you know what, any instances that have missing values, I'm just going to ignore. And that's what I'm going to do here. I'm just going to ignore them. Okay, and the way I'm going to do that is with a list comprehension here, where I'm going to specify, again, something I'm by convention using as a named constant, unknown value, which will be the question mark. And then I'm going to build a set of clean instances by going through all instances and binding instance to each value in all instances. If unknown value is not in the instance, that is, if the string question mark is not in the instance, then I'm going to save it in the clean instances. Otherwise, I'm not going to do anything to it. Okay? And I'm going to print the number. So I went down from 8,100 and something or other, right? 192, I can't remember now, down to 5,600 clean instances that have no missing values. Okay? And using list comprehension, I can do the same thing. So here I'm just saying, for each instance in all instances, if unknown value is not in the instance, then return that instance. Okay, so this is doing the exact same thing, only it's expressed all within a list within the brackets. Okay? So I'm getting the exact same thing. Okay, I was asked about dictionaries before, or associative lists. So a dictionary is a set of keys and values, and many programming languages have this. This comes in handy in lots of different kinds of contexts. And as an example of this, I'll declare a dictionary and I'll explicitly declare each of the keys and values of that dictionary for the values of the cap type attribute. Okay? And then just to kind of show it, I'll set a variable to one of those keys, and then I'll print that key and then the value of that attribute. Okay. I can also print the values of all of these by just iterating through this. Essentially, when you iterate through a dictionary, it's going to bind the variable that you're using to iterate through it to each key. And then you can actually then use that key to pass in here. I'm trying to think here. Yeah, this is essentially just passing in the key to the function that returns the value associated with that key. You can also do dictionary comprehensions. I'm not sure if this is getting too complex, but it may actually help you understand more about what's going on with the list comprehension. What I'm doing here is I'm building a dictionary where each key is the first element of X, and each value, whoops, is X. And then I'm going to iterate through these tokens. So the first time through, X is going to be bound to Bell, X0 is going to be B, and X is going to be Bell. So I'm essentially going to iteratively through build this sequence of key value pairs, and it will give me the same thing. Except that, note that convex uses the last character, and I decided I didn't want to complicate this code to include it, so I'm just going to conveniently ignore it. So the basic idea is the same. You're iterating through a bunch of things, and the first thing you specify in the comprehension is the thing you want to collect, aggregate from the things that you're iterating through.
Exactly. The first thing is not the key, but rather the things you want to collect.
Well, what this is doing is essentially aggregating. The thing that's specified here is essentially what are the things you're aggregating. In this case, it's key value pairs. In the list comprehension, it's just the individual items of the list. And so that's essentially saying that what you're going to collect each time through.
So can that be like a list in itself?
Yep. Yeah, so I'm creating a list of lists. Yeah, in fact. Let's do that. I'll change this to a list. And then, or I can make it a list of tuples. How about that? Okay, or if I want a list of lists, I'll just change that to brackets. Okay, does that help? Mm-hmm. Okay, so let's see here. This function is putting a lot of stuff together, including a lot of I forgot to mention before, you can include documentation in a function by just having this multi-line comment delimiter. So you have these triple single quotes or triple double quotes, depending on your preferred mechanism. And then you can have as much documentation as you want at the very beginning of the function. So this is a function that's going to actually load the attribute values from a file. And what it's going to do is it's going to assume that each element of the file has a name, a colon, and then one or more value description equal value abbreviation. So as an example, each line of the file, so one line of the file will have cap shape, colon, then bell equals B. So essentially for each of the possible values of cap shape, we're going to provide the fuller description and then the abbreviated description. Okay? So we are going to, and at the end, we're going to return let's see here, what are we going to turn? A list of dictionaries, I think. Yeah. So because we're going to have several lines, each of which is going to describe an attribute, we're going to create dictionaries associated with each of these. Okay, so we're going to set the attribute value descriptions to the empty list, open up the file, iterate through each line in the file. We're going to strip the line, and now first thing we're going to do, we're going to split on colon. Because the colon is going to separate out the attribute name from the value descriptions and abbreviations. Okay? So the attribute name is going to get the first element. Now, there might not be any value descriptions there, so we'll check that, and then we'll just append an empty dictionary to that. So if you have curly braces, that's just an empty dictionary. Otherwise, we have one or more sets of attribute value descriptions and attribute value abbreviations, each of which is separated by an equal sign, right? So as example right here. Okay. Now, we're going to, in each case then, we're going to start then with the attribute name and values. Remember, that's the second element of this list that was split on the colons. And then we're going to strip and split on the commas. Okay, and that's going to separate out into individual elements. And then that in turn, we're going to need to split on the equal signs. all right, to separate out the description from the actual value. Okay, so we're going to actually create a list. And one of the things I sometimes do when I'm going back and forth with like strings and lists and then individual elements, I just start putting an underscore and then a list. Oh, one thing I forgot to mention earlier, you may have noticed this already, Python tends to use all lowercase for its names, except for classes which start with an uppercase character. Java often uses camel case. Other languages have different conventions, but in Python, the convention is to use underscores to kind of separate the different elements that go into a name. Okay, so here now we're now into another level, a nested for loop that we're iterating through each description and abbreviation, where that was set up by the things that are separated by commas, and now each of those things we're going to split by equal signs. We're going to say the description is the first thing, and then we're going to check to see if there's more than one thing. If not, we're not going to do anything with it. If there is, we're going to set the abbreviation to that second thing. Remember, this is zero-based indexing. And then we're going to say the dictionary entry for that abbreviation is going to be the description. After we've built, so notice how this level of indentation here, this statement right here, gets executed after this inner for loop is done. We're then going to take this dictionary that we just built up with all the description equals abbreviation splits, and we're going to append that to the overall set of attribute value descriptions. And then at the very end, so this return statement here is at the same level of this with. So this is after it's done all the processing. We're going to return this aggregated set of attribute value descriptions. Okay, so, and there you can see it's got a list of dictionaries. The first dictionary entry is the, actually what I should do is, no, I won't show you all the file. Well, actually, let's see here. I will show you because this will give me an opportunity to demonstrate something else. Inside IPython notebooks, you can execute, well, can you do this on Windows? I don't know what happens if you do this on Windows. You would probably use type instead of cat in Windows, right? If you want to see the contents of a file, you can try it. I'm using a MacBook here, so I've got OS X underneath it. So essentially, I can say cat, which is the equivalent of the DOS type command, and show the contents of the file. I can run a bash command right from a cell in Python. I don't know if it will work in Windows. Has anyone tried it yet? It's the exclamation point and then the command. Did it work? Yes. All right. So there you can see there's the 23 lines of that file. And I could go through and it correctly set up the poisonous versus edible. And then I guess just for completeness, let's see here. Whoops. Insert below. Attribute values. Oh, let's show the first three. Using that, remember that slice notation. Okay? So there you can see it seems to have correctly built the dictionary of all these things. Yes? If you're on a Windows machine, you have to use type instead of cat. I think, is that what you used to get it to work? Type? T-Y-P-E? Okay. Questions on that? Yes?
The line where it's grab this predict some not equals this. So there the keys.
The line here?
Yeah. So what can you explain this line?
Yeah, so I wanted to have something in there. So if there's no, so I've got the description in the first thing, but what if there's an error in the file or there, something got lopped off? And so essentially there is no abbreviation, so I'm just using none as a placeholder, and I'll give that, and that'll be something that I might be able to debug later. Is none one of the keys in the dictionaries that I'm returning?
So you can actually have none as a key.
Yep.
In the dictionary, you can say dictionary sub none.
Yep. Yeah, and yeah, the problem here though is that if there's more than one that doesn't have one, then I'm just going to get the last one. I should really just build a list of them, but you know, this simplified the code. But good question. Yeah, none is a legitimate key for a dictionary. Other questions? Okay. Oh, I see. That's where it went. Whoops. I just mistakenly deleted a cell I didn't want to delete, so I'm going to go back here and undelete the cell. Oh, I guess I did want to delete that one. Good. Uh-oh. Somehow I get the feeling, did I delete more than one cell? Oh well. I'll say this and you can, I'll see if I can interpolate anything I mistakenly took out. Okay. Boy, it's almost quarter of. I'm not going to give time. I'm not going to allocate time for you to do these things. And plus, I mean, you could probably copy and paste to make a few changes, and you get the idea. The first several exercises are geared to just kind of get you used to defining functions, you know, and getting indentation right, and a few other sorts of things. Later ones will give you more of an opportunity to exercise things. I'm probably not even going to get to the second part of the tutorial, but it's all there for you. I'll try to at least give you an overview and get to the back, end of the first one here. One of the things that's really useful in Python is counting things. And there's actually a special subclass of dictionary called a counter that can be used to count the number of unique elements in, say, a list or other sort of structure that you're working with. So, for example, we might want to count the number of instances that are edible. And one way we could do that is declare a variable set to 0, and then for each instance, if the class, which is stored as the first element of each instance, is E, then we'll increment the number of edible instances. Okay? So there are 3,488 of those 5,644 instances that are edible. Let's see here. This is going to get a little bit more complicated here, but we could also get a count of the different values of the cap state attribute. Now remember, the class label, the first element, only has two possible values, E and P, for edible and poisonous. Other attributes have multiple values. So one of the things we could do is create a dictionary that keeps track of the counts of each of the values of each attribute. In this case, we'll just do it for cap state counts. So for each instance, we're going to grab the second attribute of the instance, because cap state is actually the second element in each of those instances. If the cap state value is not already in the dictionary, we're going to set that dictionary entry to 0, and then regardless of whether it already was or not, it now is in the dictionary. Now we can increment that count by 1. Okay? This is a programming paradigm you've probably used in other languages as well, right? Okay, so there we see the distribution of counts for the different values of the cap state attribute. Now there is a counter class in an external module called collections that we can use that is a much simpler way of doing this. And the way we're going to use this is there's two different ways we could do it. We could import collections just like we imported simple ML up above, or we could say from collections import counter. And then we can use counter without the dotted notation. And that's the way we're going to use it here. Okay? So there's going to be two variations of this. The first one, I'm just going to eliminate the need to initialize each counter to 0 because that's done for us by the counter class. Otherwise, we can use it exactly like we would a dictionary. Okay? So essentially, this is the same code copy as above. I just deleted the if statement and the need to initialize things. But a counter object is actually more powerful than that. I'm going to give you a simplified version here of how to use it. So I'm going to declare a variable of counts. I'm going to set it to a counter, and I'm going to pass in a list. And it's automatically going to go through that list and count the number of unique occurrences and return a dictionary with each item in the list and the number of number of times that value occurred. Okay, so here's a list with ABC, ABA, and the A occurs 3 times, the B occurs twice, the C occurs once. Okay, and that's essentially what it returns. A counter now with with each of those individual elements and the counts, the number of occurrences in that. Now, I'm going to do the same thing here with a list comprehension. What I'm going to do is this list comprehension right here, and you know what I'll do? I'm going to set this out a little bit. I'm going to copy this, put it up here, and that's just going to build the list comprehension. And now at the very end, because I don't want to show all 5,644 examples of this, I'm just going to say, show me the first 10. Okay, so I can use this slice notation for any list, not just list variables, but actual list expressions, okay? So what that's showing you is that just going through each instance, and it's grabbing the second element in each instance and then returning that. Okay, so if I show no, I'm going to print clean instances because I'll put all one. Okay. So you can see here, you look at the first 10 instances, XXB, XXXBB, XB. And sure enough, XXB, XXXBB, XB. Okay, so it's all it's doing is it's kind of picking out each element, collecting it into a new list, and it gives me a very compact way of saying, get me the the second element of every instance in this list. Okay, so now I pass that thing into the counter, and it's going to give me the same thing that I had to build up much more laboriously up above. Okay, so it's a quick way to get the counts of things. Let's see here. Yeah, I'm going to skip over this. This is just a kind of encoding, taking the code that we did above, but writing a function for it. But we're running out of time. I'll leave that as an exercise you can do afterwards. I also just mention here that another thing we often want to do is to be able to sort a dictionary not by its keys, but by its values. And this section I'm not going to go into because we're running short of time. We'll show you how to do that. Although, I'm sorry, this actually, here, I will show you this. This is actually using sorted again here. If we can say, we can call sorted on dictionary, and it's going to sort the keys and return a list of the sorted keys of the dictionary. So up here, notice that the order in which it was returned is not sorted. So I'm not going to go over this section here on sorting a dictionary by values.
Question.
Yes?
You're reading comments on your document. How do you add those? When I try to edit, it ends up as a Python code.
If I try to edit this? Yeah.
Any comment box like that.
Okay, so if you look up here, see how it says markdown?
Okay.
There's two basic kinds of cells. Some are markdown cells where the text is, and I can do the links and all the other stuff, and others are code cells. So so I'm just going to go here, and then this one here, notice how it says code. If I want to change the type, and I do that sometimes, I hit escape and M, I think is how you do the markdown mode, and escape Y, switching code mode. If you accidentally do it and you don't know the key shortcuts, you can just go up there and manually change it. Mm-hmm. Okay, I'm not going to go through the sorting by values. It's an important thing. I'll mention here that string formatting comes in really handy. Most languages have something like printf or something that lets you specify the field width and precision for floats, for example, and even justification of how to have things format. Python also has that capability. So, for example, in this case, the 5 is the number of places to use, and 3 of those will be devoted to decimal places. This will give it a little more room. It'll take a total of 7 spaces to print something, 3 of which will be after the decimal point. I'll just show you there. If you want to pad things with leading zeros, you just stick a 0 right after the colon. The D is used for integers to format those, and you can similarly pad those with zeros. Strings can similarly, with an S, specifier can be printed out, and I think if you don't specify S, F, or D or anything like that, it'll just default to assuming it's a string. If you want to write justify a string, you need to put the greater than sign because otherwise strings are left justified by default. Okay, so here's an example where I've broken up things into several different lines. A single print statement, printing out a few different things, and keeping on the same line. This is separate print statements accomplishing the same thing. And this kind of thing, you probably run into this kind of thing where it's handy to kind of have a whole bunch of things on a line, but it wouldn't all fit on within a statement. So I'm going to skip over this exercise, and unfortunately, with 7 minutes to go, I'm not going to be able to do justice to what was supposed to be the second part of the tutorial. I do have a link to a survey, though, that I'll show you momentarily, because maybe I was going too slow. I don't know. Or maybe there were things that you don't find all that in. I thought I had chopped it down so it would fit into 2 hours. Clearly it didn't. But I'll just briefly describe what's in this next section so that you can go through it at your own pace at a later time. Essentially, the goal here is to use Python to construct and then use a decision tree to classify mushroom instances. Okay, and this is a pictorial representation of a decision tree that would be that was trained on the entire set of instances, the 5,644 instances. A decision tree is essentially a way of classifying things where you, at each level of the decision tree, you look at a specific attribute, and it's a test of the value of that attribute. And then depending on the value of the attribute, you follow one of the branches below that. So in this case, it's going to take the odor attribute, and if the odor is musty, or actually if the odor is anything other than nothing or none, that is, there is no odor to this mushroom, then you're going to be able to classify it right away. In other words, odor is a very informative attribute because it gives you a lot of information about the poisonous or edible nature of a mushroom. If there is no odor, okay, now you got to go ask some more questions. What's the color? Okay, well, it could be any of these things, and then, most of these of which will get you classify it right away then. But if it's white and odorless, now you got to look at the habitat. And then there you also get a lot of information. And then if it's in leaves or in woods, then you have to check either cap color or gill size. Have you seen decision trees before? This is a fairly common machine learning algorithm. So anyhow, there are a few things that are different about this data set than you will see much of the rest of the conference here. So scikit-learn, there's actually a tutorial right now on scikit-learn, and I encourage you to look at it at some point, uses only numerical values. These are all categorical values. They're these strings or characters that indicate values. A lot of times it's going to be integers. So unfortunately, I'm not going to be able to go into things like entropy and information gain and all the fun things that kind of go into giving a decision tree its power. But there's a lot of code here that you can look over and execute. There's an algorithm here. It's a very simplified version of a decision tree algorithm. It's the original. I don't know if it's the first decision tree algorithm. It's the first one I ever learned. ID3, which will essentially recursively build a tree, and this will step you through it. Again, adding new information about things you might find useful. There is some things here about evaluating it. There's in terms of trying to figure out how well a tree is going or is performing. And then at the very end here, as you can see why I'm kind of rapidly scrolling through this and why we're not going to quite have time to do justice to this. At the very end also, there's a brief introduction to object-oriented programming. There's some stuff on learning curves here. Whoops. So there's also, the very, very end, there's a little bit about how you define a class in Python. And what this does essentially so all the thing I just scrolled through are all the steps for building and evaluating a decision tree. But just using, the regular Python we've been using. I then take all that code and redefine it as a class, and rather than making an exercise, it's all right there. And I also adopt the terminology that's used by scikit-learn and many other open source machine learning libraries. So it talks about fitting data to a model versus, say, training or creating a model. And then you can look all that over as well. And then at the very bottom here, there's next steps as far as things you might do. If you were to use Python and carry things on, I'm hoping this is provided, even though we didn't go through the decision tree, many of the elements of Python we did cover that I think are crucial. You'll see things like NumPy and SciPy, which are for numerical and scientific computing. Pandas, there's a great pandas tutorial here that you might go to as well. So there's a lot of other things built on top of this once you have a solid foundation. In fact, it's all these other libraries, I think, that really give Python its power and why it's an increasingly popular language in machine learning and data science. And there's a bunch of other tutorials here as well. So we're almost to the end of our time here. I just want to say that there is I have created a survey because I'm eager to know how is this for you. I know how I thought about it. I want to thank Alex and Brian for being hands-on here and going around. And I'm sorry if not everyone got a chance to install everything, but thank you for coming and for the conference organizers for allowing me to share some of my enthusiasm for this language. I'm going to be around for the rest of the conference. You can email me at that link. And then there's a survey here. I'd welcome your feedback. So it's bit.ly and then PyData, note this capitalization, _tutorial_survey. And if you take a few minutes, I hope you'll give me some feedback on it. It's just kind of getting a sense of, where are you coming from? What kind of languages have you used? And, and then what could make this even better if we were to do it again? So thank you very much for your attention. It's just about lunchtime. I'm happy to hang out here for a little bit and answer questions.